Okay, I've got one more example of finding distance between parallel lines. Okay, so your first step, again, is to pick an equation. And it doesn't matter which one you pick, although to keep it pretty similar to what the book is doing, I'm going to pick the one that they pick to start with, and that's going to be y equals 2x minus 3. Since I wrote it down, I'm going to cross them out so I know I don't use them later on. I need to find an equation that is perpendicular to this one. So I know a point that goes through this line is 0, negative 3, based off of my y-intercept. And I also need a perpendicular slope, which is also going to come off this line. So if my slope is 2 from my original, my perpendicular slope is going to be negative a half, opposite reciprocal. I have a slope, I have a y-intercept, so we're going to plug it into y equals mx plus b. When I plug it in, we're going to get y equals negative a half x minus 3. I'm going to star this guy again because I'm going to need him for step 3. And then we're going to go on to the next one, solve system of equations. So you're going to have to use the equation that you got from step 1, so negative a half x minus 3, and the one that you did not use, so y equals 2x plus 1. Again, I'm trying to find the intersection of these two lines. Looking at it in terms of the graph right now, I'm trying to find this intersection point. Okay? The easiest way to do this, again, is since y equals them, I'm going to use substitution. Okay, so I'm going to set both parts equal to each other, so I'm going to have negative a half x minus 3 equal to 2x plus 1. I'm looking for an x and a y. We'll go ahead and solve this. I'm going to add a half x to both sides. When I add a half, that's going to give me 2.5x. And then I'm going to subtract 1. When I subtract 1, that's going to give me negative 4. I'm going to use decimals this time. When I divide by 2.5, that's going to get me negative 1.6-ish. So that's going to be my x value. Next, I have to find a y value. I can pick either one of these. I'm going to choose the bottom one just because there's no fractions involved in it. So I'm going to plug my negative 1.6 into this equation. So I've got y equals 2 times negative 1.6 plus 1 to find the y value of my point. And when I plug that in, that's going to get me a value that's pretty close to negative 2.2. And we can scroll back up and look at it in terms of our graph. These are going by ones, so 1, 2. It looks like I am short of 2 for my x value, so that seems pretty reasonable for negative 1.6. And then 1, 2, I'm just past 2, a negative 2 on my graph. So negative 2.2 seems pretty reasonable for a point as well. So I'm going to use that point and the point from step 1 to find the distance. So big square root, 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. I'm using 0, 3, and I'm using negative 1.6 and negative 2.2 into my formula. So plug in our stuff, big square root, let's go on negative 1.6 minus 0 squared plus negative 2.2 minus 3 squared. When you do all of this and plug it, you can plug it straight into your calculator, and I would because it's got decimals in it. That's going to get you a distance of 3.2. Again, I'm going to leave it like that. You can certainly find the decimal approximation if you'd like. I'm just going to leave it in terms of the square root. But that's going to be your answer, and that's your distance between your two parallel lines.